Hey everyone, and welcome! Today, we are diving into one of those super important ideas you see everywhere in math, perpendicular lines. And trust me, they're not just on your homework. They're in the room you're in right now, they're in the layout of entire cities, and they all follow this one secret mathematical code. So in the next few minutes, we're going to unlock it together. So here's what we've got on deck. First, we'll talk about what perpendicular really means. Then, I'm going to share the simple two-step secret for spotting them on a graph. After that, we'll put that secret to the test, look at a few common mistakes you'll want to avoid, and finally, see how this one little concept literally shapes the world around us. All right, so first things first. When we say two lines are perpendicular, what are we really talking about? Let's kick things off with a pretty cool image. I just love this way of putting it. It's not just two lines crossing paths, It's a perfect head-on crash. This isn't some gentle merge on the highway. It's a super precise intersection that forms that perfect corner every single time. Okay, so stripping away the drama for a second, here's the official definition. When lines intersect at exactly 90 degrees, boom, they're perpendicular. And honestly, the easiest way to picture this is to just look around you. Right now, the corner of your phone or your computer screen, where the wall meets the floor, those are all perfect real-world examples of perpendicular lines. All right, now for the good stuff. How do we spot these lines on a graph if we don't have a protractor handy? Well, it all comes down to their slope, and there's a really simple two-step secret to figuring it all out. The key phrase you need to burn into your brain is negative reciprocals. I know, it sounds super technical and complicated, but I promise you, it's just a fancy name for a two-part code that is so easy you're gonna have it down in like the next 30 seconds. And here it is. This is the secret code. It's just two simple things. First, you flip the fraction. So if you have 2/3, it becomes 3/2. Easy enough. Second, you switch the sign. If it was positive, you make it negative. If it was negative, you make it positive. That's it. Flip and switch. Done. And here's what's so cool about this. Our little flip and switch rule isn't just a memory trick. It's baked right into the formal math. See, if you take a slope and multiply it by its negative reciprocal, you will always get -1. This formula is just the mathematical proof that our secret code works every single time. Okay, enough theory. The best way to really get this is to just do it. Let's put our new secret code on trial and run through a couple of examples. Let's start with a whole number, something like 4. You might be thinking, how do I flip that? It's not a fraction. But it is. Just think of 4 as 4/1. Now apply the code. Step 1, flip it. 4/1 becomes 1/4. Step 2, switch the sign. It was positive, so now it's negative. And there you go. The perpendicular slope is -1/4. Simple? Let's do one more, this time with a negative fraction. Our starting slope is -2/5. Okay, you know the drill. Step 1, flip it. That gives us 5/2. Step 2, switch the sign. It was negative, so now it's positive. Our new perpendicular slope is +5/2. See? Same 2 steps every single time. Okay, time to level up a little bit. This is where this algebra skill becomes absolutely crucial for geometry. We've got the 3 corner points of a triangle. Now the big question is it a right triangle? To figure that out, we need to know if any of its corners form a perfect 90-degree angle. And how do we do that? You guessed it, we check the slopes. So our mission is to see if any 2 sides of this triangle are perpendicular. Let's start with the corner at point A. First, we need the slope of the line connecting points A and B. We use our slope formula, and we get a slope of 4/3. Okay, part 1 is done. Now, let's check the other line that makes up that same corner, the one from A to C. We run the numbers again, and the slope for that line comes out to -3/4. So for angle A, we have 2 slopes to compare, +4/3 and -3/4. And here we go, the moment of truth. Let's look at our 2 slopes. We have 4/3 and -3/4. Do we flip the fraction? Yep. 4/3 became 3/4. Do we switch the sign? Yep. Positive became negative. They are perfect negative reciprocals. And that proves that angle A is exactly 90 degrees. So is it a right triangle? Yes, it is. Now, this flip and switch rule is pretty straightforward, but there are a couple of little traps that people sometimes fall into. So let's shine a light on them right now so you can just sidestep them completely. Okay, this is by far the #1 mistake, only doing half the job. People are great at remembering to flip the fraction, but they totally forget to switch the sign. But just think about it logically for a sec. If you have two positive slopes, like 2/3 and 3/2, both of those lines are going uphill. There's no way they can ever meet at a 90-degree angle. You have to do both steps. Remember, flip and switch. And here's the one little special case you gotta know: horizontal and vertical lines. A flat horizontal line has a slope of 0. Now, if you try to flip 0, which is like 0/1, you get 1/0, and you can't divide by 0. That's what we call an undefined slope. And guess what? That's the exact slope of a vertical line. So the rule kind of works, but the easiest thing is to just remember this: a horizontal line and a vertical line are always a special perpendicular pair. So, okay, we can find them on a graph, we can solve geometry problems, but why does this actually matter, like in the real world? Well, it turns out this simple idea is literally the foundation that some of our biggest cities are built on. I mean, just picture a map of a city like Manhattan. It's not just a random mess of streets going every which way. It's a grid, a very, very carefully designed grid that's built almost entirely on the idea of perpendicular lines. And this design is just brilliant. You have the avenues running one way and the streets crossing them at perfect 90-degree angles. This creates all these neat rectangular blocks that are just perfect for buildings. It maximizes all the usable space, and it makes finding your way around super, super easy. It's a whole system built on the power of the right angle. So, after all of this, what is the one thing you absolutely need to remember? It's this: when you see the word perpendicular, your brain should immediately scream negative reciprocals. And if you ever have a moment where you blank on what that means, just remember those two magic words: flip and switch. So now you have the secret code. You can spot these perpendicular lines in an equation, on a graph, or even hiding inside a geometry problem. So I'll leave you with this question. Now that you know exactly what to look for, where else are you going to see these perfect 90-degree angles shaping your world? Look around. I think you're going to be surprised.